Question 5b. When an equivalent AC supply is applied to the circuit instead of a DC, this upper light bulb does not light up, but the lower one does. Explain. Okay, so over here we've got a little bit of animation. 50 Hertz is what comes out of the normal AC power supply on the wall. Okay, and we've got our two light bulbs. Okay, and we can see that this light bulb's flickering. It's going on and off 50 times every second. Well, you notice this light bulb's not going, and the question is why? Well, exactly the same sort of principle as what happens in 5a. This inductor creates a back EMF from Faraday's law that voltage equals negative the changing magnetic flux, and there's a changing magnetic flux is because the current's constantly changing. It's going forwards and backwards, so the current's constantly changing, so the magnetic flux is constantly changing. Magnetic flux is constantly changing, it's constantly inducing a voltage in the opposite direction. So if the power supply was plus, then this end would be plus, and it's sort of undoing what the power supply is trying to give. And so essentially very minimal voltage or very minimal current gets to go through this, and so there's very minimal voltage lost across this light bulb, so it doesn't essentially glow very much. When we do AC later on in the topic, you're going to soon learn about something called impedance and inductance. So inductance is like the resistance of the inductor, okay, which is equal to 2 pi f, which is the frequency, times this value, which is specific for every inductor. Okay, in this case it's 60 henries. Okay, so what that means is as frequency increases, the voltage or the resistance of the circuit increases. So if I made that something like 2 hertz or 0.2 hertz, we can see that it does actually light up. Okay, but as frequency grows, the resistance, if you like, of the inductor gets bigger, and so less current can flow. If we wanted to look at a more formal sort of answer, it says the light bulb lights up because the AC voltage applied to it causes the normal current to flow through it via Ohm's law, and the filament grows. So this is that bottom one with a normal sort of frequency of say 50 Hertz. It just glows normally, but the upper bulb has an inductor in series with it, which produces a back EMF electromotive force that always opposes the AC current. Okay, so when that's plus, then that's minus. When that's minus, that's plus, and it's always undoing what that's trying to do, and so it prevents the current from flowing in a similar way to 5a. This means that the current passing through the light in series with the inductor is always small, so the light bulb does not light up, which is exactly what we see in our animation.